Hello, welcome back. Math 128, lesson 12.4, which is addition and complement rules. We're going to talk about mutually exclusive events today. Two events, A and B, are mutually exclusive if they cannot occur at the same time. That is, A and B are mutually exclusive when their intersection is equal to the empty set. So this right here says A intersect B equals the empty set. So that means they have nothing in common. So we're going to find the probability of mutually exclusive events. The probability of A or B occurring is the same as the probability of A plus the probability of B. Again, I'll write that in case you're having trouble seeing it. A or B equals the probability of A plus the probability of B. So we're going to go back to our two fair dice being tossed. And we're going to find the probability this time of rolling a 7 or an 11. We did a 7 last time, so we'll go ahead and do it really fast. 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. So event number 1 is getting a sum of 7. Event number 2 then is going to be getting a sum of 11. So this is going to be our first event. This will be our second. So let's look at things that would add up to 11. Well, 5 plus 6 equals 11. So when I'm looking here, I want to go into the 5 column, and 5 and 6 will equal 11, and 6 and 5 will equal 11. So there are 2 ways that that one can occur. Again, we did the sum of 7 on our previous lesson. There are 1, 2, 3, 4, 5, 6. Of those. So the probability of E1 equals 6 out of 36, because there's 36 possible. The probability of E2 equals 2 out of 36. Now, in this case, I'm going to leave them in this format. I'm not going to put them in lowest terms because we have to add them together. So the probability of getting a sum of 7 or of 11 equals the probability of getting a 7, 6 out of 36, plus the probability of getting an 11, 2 out of 36. When we're adding with fractions, we need a common denominator. So notice they both have 36. So in this case, we're just going to add the 2 top numbers. 6 plus 2 is 8. The bottom number stays the same. If you have an ABC button on your calculator or something that looks like this as a fraction button, you can use that to help you when working with fractions as well. So I have 8 over 36, and then I'm going to simplify that. Well, both of these will divide by 2. Both of them will divide by 4. So 4 goes into 8 twice. 4 goes into 36 9 times. Again, if you have that button on your calculator will simplify your fractions for you. We want to make sure that if we are using this formula, that there is nothing that they have in common. There are no pairs that add up to 7 and 11. And in this case, that is the case. We've got our 7 sums circled and our 11 sums boxed, and none of them are the same. Mutually exclusive means they have nothing in common. So as we're looking at this in table format, the other thing we want to keep in mind is, and I do apologize that this is too light, so I'm just going to write it again. If they have something in common, then we don't want to count it twice. So we have probability of A plus probability of B. But if they have something in common, we want to subtract that overlap. And we're going to call that the probability of A and B. And then I'm going to write that word overlap. We're subtracting anything that we count twice. So as we're looking at this one, it's going to be really important to keep in mind that if there are numbers that are the same, or if there are things that are in common, then we want to keep them and subtract them at the end. So I'm going to give you some numbers here. So this is going to be 0, then 4, 7, 12, and 12. I hope you are taking notes and writing these things down. This one's going to be 4, 16, 21, 35, and 22. This column's numbers are going to be 2, 3, 5, 5, and 4. And then the last column is going to be 12, 16, 15, 7, and 5. We're going to be looking at categories of salaries. So salary is our category we're going to look at, and we're going to look at different jobs. So the first one is an engineer. The second one is going to be business. Our third one is going to be chemistry. And then our last one is going to be psychology. This first category is going to be less than $20,000. The next one's going to be 20,000 to 24,999. Then we're going to do 25,000 to 29,999. Then we're going to do 30,000 to 34,999. Again, these are all the salaries. And then the last one is going to be 35,000 or more. Okay. So I'm going to go ahead and draw in some lines here. Make sure that still looks like 12. So that we have a table to look at. This information will be given to you either in the textbook or the homework problems or on the test. And so in this table, it says that data in the table shows starting salaries of college graduates with select degrees. And then it says, if one person is chosen from the population, what's the probability the person has a degree in business or a starting salary between 20,000 and 24,999. So we want to look at two pieces of information. Our first event is going to be that they have a degree in business. Our second event is going to be that their salary when they start their job is between $20,000 and $24,999. So we have to do some totaling because remember, for probability, we need the number of favorable over the number of possible. So we're going to do a little adding. So as we are getting started, let's add up all the business numbers. So that's this column right here. So I'll write those down here as we're doing them. So business is equal to 4 plus 16 plus 21 plus 35 plus 22. So grab your calculator and go ahead and come up with that total number. Hopefully you get an answer of 98. Then we want to look at the values that are in the category 20,000 to 24,400 or 24,999. So that's this row right here. So then we're going to look at the salary second. It's just a smidgen bigger so we can see all of it at once. And the salary numbers are the numbers 4, 16, 3, and 16. So grab your calculator and go ahead and total up those. 4 plus 16 plus 3 plus 16. Hopefully we got 39. So circle those two numbers because we're going to need those. And then the last thing we need is the total from the table. So we need to add up all of these numbers. So starting with this 0 in the corner, 4, 2, 12, 4, 16, 3, 16, 7, 21, 5, 15, 12, 35, 5, 7, 12, 22, 4, and 5. So take a minute and add those up, and that will be our total of the table. Again, hopefully you get 206 for that value. Okay. Now looking at the table, it's fairly easy to see what gets counted twice. So which number is in both the row and the column? Hopefully you see that that is this number 16. We counted it in both. It is here when I added up the business, and it is here when I added up the salary. So when we talk about the overlap or something that's counted twice, that's what I'm referring to. Okay, I'm going to scoop this up and add in some more paper because I write really big. And then we'll keep doing this here because we're not finished. Grab a little piece of paper here. And what our next thing we want to do is to do our probability. So what it asked us is, what is the probability the person has a degree in business, or they have that starting salary of $20,000 to $24,999. So this is equal to the probability of our first event plus the probability of our second event minus the probability of E and E2, or the overlap, I'm going to keep calling it. So the probability of E has to do with business. We had 98 out of 206. So your first fraction is 98 out of 206. E2 then is 39 out of 206. And the part of overlap, or what got counted twice, is this number 16. So we're going to take off or subtract 16 over 206. Again, probability is always the favorable over possible. So favorable, number of business, possible, total of the table. Favorable, number in that salary row, possible, 206. How we got overlapped, the piece that's in both, 16 out of 206. And then go ahead and do that subtraction. I'll grab my calculator, you grab yours. So 98 divided by 206 plus 39 divided by 206 minus 16 divided by 206. Now, my calculator, I have to put them in parentheses. Or if you're using your ABC button or that square over square button, that should work as well. And then I get a decimal answer of 0.587,378. And it continues, but remember, we only need 3 decimal places if it doesn't tell us otherwise. So 0.587 or 58.7%. To change a decimal to a percent, we move the decimal point 2 places. Remember, again, these are approximate values. If you need an exact answer, then you need to leave it in fraction form. In which case, you would do 98 plus 39 minus 16, and that would give you 121 over 206. Again, if you are doing homework and it asks for an exact answer, then always leave it in fraction form. So all of this is for the addition rule. We have 2 different things we've done the addition of. When there was nothing in common, mutually exclusive events, and when there was something in common, and that's when we subtract that overlap, or what we've counted twice. The next part is the complement of an event. This is again a definition. If E is an event, then E complement is going to look like this. So E is your event. Then we can have E complement or E prime. This is your event. And then this is your complement. So if I list the numbers 1 through 6, as my sample space, and I give you an event of odd numbers, then the complement, either E with the little c or E with the little prime, looks like an apostrophe, is everything that's not in this event, but is in the sample space. So in this case, that would be 2, 4, and 6, the even numbers. The complement is everything else. If you know a probability of an event, say, is 1 out of 5, then the probability of the complement is going to be 1 minus 1 over 5, or in this case, 4/5. Again, it's everything that is left after you take out that event. So let's look at example 3. The probability that a person has type A blood is 34%. What is the probability that a person does not have type A blood? So the probability for type A blood is 34%, or 0.34 if we write it as a decimal. So the probability that they do not is going to be 1 minus 0.34, or 0.66, or 66%. Now, why did I change it to a decimal? Well, I'm subtracting from 1. If I'm talking about a percent, then I would have to subtract from 100. So this is still allowed, but notice the difference. If I want to use the formula, which is that I take 1 minus the probability, then I would have to, in this case, realize that 1 or a whole is the whole 100%. So you're better off always changing it to a decimal than possibly making a mistake and not thinking about that. Okay. All right, for example 4, you may want to look back to a set of dice when you're rolling 2 dice or 2 die or 2 number cubes, so that you can think about the options to come up with these sums. A pair of dice is rolled 3 times. What is the probability that a sum of 7 will occur at least once? So again, I'm rolling this die this time 3 times. So I would have 3 sets of dice, or 3 rolls as you do it. So I'm going to drop my dice, see what the answer is. Drop my 2 dice, see what the answer is. Drop my 2 dice, see what the answer is. As we're looking at this one, we're looking for if it occurs at least once. And there's 2 different ways you can do these. If you want to figure out at least once, twice, or all 3 times, then you can do it that way. Or you can figure out what is the probability that none of them have a sum of 7. And then I can take that answer and take 1 minus. So my at least once would be the leftovers of none. At least once would mean once, twice, or all 3 times. So if we can find the probability of none, then we can take 1 minus that answer. So first of all, let's think about ways we can get the number 7, and then how many are not the number or sum of 7. So let's look back to example 1. I'll grab my picture here. And remember that our sums of 7 were these 6 values. Remember, there were 36 altogether. So if 6 of them will give me a sum of 7, how many will not be a sum of 7? 30 out of 36. So 30 out of 36 would not be a sum of 7. Again, I'm rolling a pair of dice 3 times. The probability for each of those rolls is going to be 30 out of 36. Now, question. How many times am I rolling it? 3 times. So each time I'm rolling it has this probability. So I'm going to do this 3 times. So I'm going to draw 3 blanks. And the probability each time is 30 out of 36. Remember, this is the probability that I do not get a 7. Okay, so let's grab something, calculator here. And 30 out of 36. And we're going to take it times itself. So 30 divided by 36 times 30 out of 36 times 30 out of 36. So I'm going to go ahead and put it in fraction form first. 125 out of 216. And decimal form 0.5787037. Keep going. 0.579 if I want an approximation. Again, your fraction is your exact answer. Okay. So that is my none answer. 125 out of 216. So I want to subtract that from the number 1. And that will tell me the probability of it happening at least once. So 1 minus that fraction, 125 over 216, will give me my final answer of 91 over 216. Again, that's my exact answer. And then if I want it in decimal form, it would be 0.42129 or 421. Again, this is an approximation. The most important thing to keep in mind here is that if I'm finding it at least once, I would have to do once, twice, 3 times. So I'm better off finding the probability that it never happens and taking 1 minus that answer. Because there are 3 rolls, I have to take this times itself all 3 times. Because this is the probability of not getting a sum of 7. Okay. All right, so we used the combination formula in our last lesson. And again, I'm just going to rewrite it here so that you can see it. And then we're going to use it in the next question. So the combination of n things taken r at a time is n factorial over r factorial times n minus r factorial. Again, look back at your previous notes if you need more information about the combinations. We're going to use the combination formula with probability. So in example 5, it says the winner of a contest will be blindfolded and then allowed to reach into a hat that contains 31 $1 bills and 4 $100 bills. The winner can then remove 4 bills from the hat and keep the money. Find the probability that the winner will pull out at least 1 $100 bill. Again, we're going to find the probability of none and then use that to find our at least by taking 1 minus that answer. So our process is the same, but we're going to use our combination formula in the problem. So our event is that we have at least 1 $100 bill. And our complement is that we have no $100 bill. We're going to be choosing 4 bills from a total of how many? 31 $1 bills and 4 $100 bills. So this is a combination of 35 choosing 4. So we have 35 factorial over 4 factorial and 35 minus 4 factorial. Again, remember your calculator should have an NCR button, and you can actually do this on your calculator instead of having to do it by hand. So I'm going to go ahead and press my NCR button. So I hit 35, then that PRB button gets me to NCR, and then I hit 4 and hit enter. So this number is going to be my total for my bottom number when I do my probability fraction. Okay. So I'm going to grab a piece of paper here, have some more space. And then we're going to keep going. Hopefully you have that written down. I'm going to go ahead and move it. We'll need to look back, pause the video, and please rewind it and get it written down so that you'll have it. All right, so 52,360. I'm going to write that number down. That is going to be the bottom of our fractions when we make our probability. Probability is the favorable over the possible. So this is our possible. Okay. So let's look at our next part. The probability that we choose for $1 bills from 31 $1 bills. Remember, we're finding the probability that we do not get a $100 bill. So we're going to do a combination of 31 choose 4. Again, I'm writing it in the formula format, but if you have a calculator, you should be able to do this on your calculator. And this time I'm just going to go ahead and write the number down. If you need to have help doing that, remember, go to PRB and find your NCR location. Then hit clear, type in the number 31, then the NCR button, then 4, then enter. So our probability of not getting what we want is this number, 31,465, out of our possible 52,360. So if we want to do our 1 minus now, the probability of getting at least one $100 bill is going to be the same as if we take 1 minus this fraction that we just created. And again, I'm just going to write down the answer. You should be able to do this on your calculator. Notice my denominator is the same, and that is approximately equal to 0.399. One minus the fraction we just created. Notice our denominator is the same, approximately equal to 0.399, or 39.9%. Again, if we need an exact answer, always write it as a fraction. When you take your test, I'm going to be okay with decimal or percent. If you're doing homework, since it is auto-graded, if it says the word exact, make sure you're using the fraction. You should be able to, again, go on to the ebook and do those extra practice problems, and then click on the homework in the modules and complete those assignments. By the end of this week, you should have lessons 1 through 4 completed. Have a wonderful evening, and I look forward to talking to you again soon.